IBHL kids, so this is me explaining the 4 examples that were given to you in your notes. So this would be one of those times when we would have the conversation about how reading a question is very, very important. So in some of this it says explain, some of it says this is what you're required to make, work backwards. So we want to make sure that we're reading our questions, that we don't do things that are not required of us, and also that we make sure we do everything that is required of us. So this first one is actually has a single word in it that makes this very, very complicated, and that word is explain. So we're going to explain how to make propylpropanoate from a single carboxylic acid. So I need to know what the heck propylpropanoate is. Well, propylpropanoate is an ester, right? Okay, well, now that I know that it's an ester, I'm going to go to this handy dandy little pathways chart that I made before. And in order to have an ester, I need a carboxylic acid, which I have, and an alcohol. Okay, so esters are made by an acid and an alcohol. All right, well, I have the acid, and it's telling me that I only have one acid. Okay, and I'm guessing that that acid is probably, since there's prop in both of them, is probably propanoic acid. I mean, that makes sense, right? If it's propyl and propanoate, then it's probably propanoic acid is what I get to use. Okay, so I can turn an acid into an alcohol, right? So I'm going to go look again at my little chart. In order to turn an acid into an alcohol, I have to, purple arrow, reduce it. So I'm going to reduce half the carboxylic acid. Why would I only want to reduce half of it? Because I need the other half to be available to react with my alcohol when I'm done. Okay, so I'm going to reduce half of that carboxylic acid. So my propanoic acid is going to become propanol. There we go. Okay, well, what did I need in order to do that? Well, this is where I need the strong reducing agent. So I would need lithium aluminum hydride in dry ether with heat. I need all of those conditions in order to make this reaction happen. So then at the end of that, I'm going to have my carboxylic acid, and I'll have a alcohol, okay? Specifically, primary alcohol, if you're feeling picky today, but specifically that's what it is. So then I'm going to create a condensation reaction between the carboxylic acid and the alcohol. So my carboxylic acid and my alcohol are going to go through a condensation reaction. Well, what do I need in order to make a condensation reaction happen? I need concentrated sulfuric acid to act as my catalyst. And I will get propanoate, and then water left over. So these are my reactions that are going to happen. A reduction of the carboxylic acid, and then an esterification reaction, or a condensation reaction. Should probably be all fancy and like label things, between the leftover acid and the alcohol. Okay. So I'm going to come down here to example number 2. So in example number 2, you are required to make butanone starting from any alkene. Well, if I'm going to take a stab in the dark, I'm going to guess it's probably going to be butene. because of the bute. I can't really change number of carbons. None of my reactions have really changed numbers of carbons. It's not that it can't be done. Well, I guess other than the condensation reaction. It's not that it can't be done. We just haven't really gotten there yet. We've just been dealing with changing our functional groups. Okay, so I'm probably going to keep the same carbon skeleton. So if my ending point is butanone, I'm trying to find my starting point, which is way over here. Okay, so my ending point is a ketone. And I know that I'm going to start with an alkene. And I already took a bet that that alkene is going to be butene. But what kind of butene? Is that double bond going to be on carbon 1 or carbon 2? If it's on carbon 3, it's really basically back on carbon 1. So there you go. So if I'm going to have a ketone, I'm going to need that double bond to be towards the middle. Okay? So I'm going to bet that this is on the first carbon. So let me kind of explain that here. So CH2, CH, CH2, CH3 is what that's going to look like. So when I go to do an addition reaction, remember that Markovnikov's rule says that that hydrogen is going to go on the least substituted carbon. So that would put the hydrogen here and the OH here. Okay? So I am going to say this is going to be an addition reaction. And when I do this, in order to put, I'm going to put an OH on here. I'll explain why here in a second. I'm going to use superheated steam and my catalyst of Al2O3. So how do you even know that you're going to make an alcohol, Mrs. Miner? Well, because I know my chart, guys. So if I'm starting off with an alkene and I want to get to an a ketone, an alcohol stands in my way. So superheated steam will get me to the alcohol. Then all I have to do is oxidize it, that pink arrow, to get it to be a ketone. So this is going to make my alcohol 2-butanol. Okay? And that will be CH3, CH2, OH, CH2, CH3. Okay, so now we just said that we need to oxidize this in order to get over here. So I'm going to do an oxidation reaction. Okay, you can use permanganate, you can use dichromate, but they're telling me to say things, so I'm going to go ahead and say dichromate. I like dichromate better than permanganate. Okay, and that's really all I need in order to oxidize that ketone, right? Oxidize the alcohol into a ketone. So I would say I'm going from my alkene to an alcohol to a ketone. So remember, this is what I started with, and then I went back to the beginning to figure everything else out. That's why it's called retrosynthesis. I'm a detective. I'm going back to the beginning. Okay, so we have 2 more examples that we're going to do, and these 2 examples go forward instead of going backward. So they're the opposite of retrosynthesis. And so this is asking me, how would you turn 1-iodopropane, which is a halogen alkane, into propanal? So an Al is an aldehyde. So, I don't know, let's go figure this out. So if I have a halogen alkane and I want to get to an aldehyde, I could turn it into an alcohol. That's what's there in the middle. Okay, so my next step will be to make an alcohol. And that alcohol, since this is on the end, this will more than likely be 1-propanol. Okay? So, how do I get from here to here? So this is a primary halogen alkane. So I'm going to make a primary alcohol. So this is an SN2. Remember, primaries go through SN2. So I'm going to need to add my sodium hydroxide. We affectionately called her a hoe earlier, but oh well. And in an SN2, I need an aprotic polar solvent. So remember, that's going to be something that does not hydrogen bond. Okay, so we're going to need like our ketones and some things like that. Okay, so then I'm going to make my alcohol. Well, how do I get from the alcohol to the aldehyde? Well, we said that to get from an alcohol to an aldehyde, we're going to go through oxidation. So we're going to oxidize this. And when we oxidize this, we want to make sure that we stop at aldehyde and don't continue on to a carboxylic acid, because we don't want a carboxylic acid. So this would be an oxidation reaction with something like dichromate. And we would use a distillation apparatus in order to collect the aldehyde before it's allowed to continue oxidizing to become a carboxylic acid. Okay, so here's one down here, and this one is probably the hardest example because we talked about this, but not in terms of using nitrogen and using amines. Okay, so how would you convert ethene? So ethene is an alkene into, this is my phone again. And I want ethylamine, which is an amine. I do like that it has that in the title, because otherwise sometimes I would just forget that an amine is an amine. You know what I mean? Sorry, I haven't gotten to make a chemistry joke all day, so. And you're a captive audience, aren't you? All right. So this is what this guy looks like. So I need to add on to there something that will allow me to substitute. And so we know that when we substitute, it's best if we can do, again with the phone, we know that if we are going to substitute, it's best if we can use like a bromine or an iodine. So we're going to go through an addition reaction here, and we know it's addition because anything having to do with an alkene, notice all the orange arrows coming off of it, is an addition reaction. And so we're going to go ahead and put it up here to a halogen alkane. Okay? So we're going to addition this with HBr. Okay? Then that will get us bromoethane. Okay? And our halogen alkane. So now that I have a halogen alkane, one of the biggest things that halogen alkanes can do are these substitution reactions. Notice these green arrows coming off of it. So in an SN1, SN2, we substituted using hydroxide to turn them into alcohol. Well, what if we substitute a different nucleophile? And so what if we go through an SN2, because this is a primary, with ammonia as our nucleophile? So again, with an SN2, we're going to use an aprotic, because we don't want any hydrogen bonding going on, but we need a polar solvent to help stabilize the, shall we call it a mess that happens? So hopefully listening to me go through these are helping you. And I'll see you guys later.